So, shh. Okay.
You know what kind of notes I like?
This is beginning, guys. So
G minor.
Right. Okay. Good. So this is beginning. Oh, good point. I gotta plug this in. Shoot.
Wait, how do you turn this in?
If I don't plug this in, we're not gonna have a video.
I like G minor. That's my favorite.
Okay, guys. Shh. John. Okay. So, does anybody remember direct variation?
Yeah.
Lila, do you remember direct variation? What do you remember about it?
I don't remember the name. So. Yeah, I don't remember the name. Something with X's and Y's.
You remember? Does anybody remember anything about direct variation?
I remember that it exists.
It exists.
Yes.
That is correct. It exists. It's y equal, this is the formula for direct variation. I'm going to put the two formulas up for direct variation, inverse variation. Direct variation is y is equal to kx.
KX?
And inverse variation, y is equal to k over x. Okay? Those are the two things we're going to talk about today. Now, direct variation, what does that look like though? Doesn't it look like something that you already know very, very well? Say it again. Say it again.
Y equals mx plus b.
Right. It's the same thing as y equals mx plus b. But what is the b?
0.
B is 0. In order for it to be direct variation, b has to be 0. And it's just the slope-intercept formula. Y equals mx plus b. B is 0. So I'm going to just erase the b. So y equals mx or y equals kx. It doesn't really matter. Some people say y equals ax. It really makes no difference what variable you use, the k or the m or an a. It just depends on the textbook or whatever, right? But just remember though, when you write an equation, you always have a y in the equation, right? When you're talking about a two-variable equation, you always have a y and you always have an x. But you don't have a third variable, usually, right? That third variable is actually a real number. It's actually called a constant. And because it's called a constant, that's why a lot of people use k, because they don't know how to spell constant. Right? So, but that is basically, that's, okay. So like if I said, if you recall way back when, I talked about if, I gave you a problem like this. If x equals 2 and y equals 4, comma, then what is y when x equals 10? All right? So this is the part they gave you that you need to use to find k, or m, or a, or whatever you're going to use. But we'll just say k for now. So you got to use this. So you plug this in. If x is 2 and y is 4, let's find k. So let's try it. So y is 4 equals k times 2, or 2, I'll just put 2 first. 2k, right? Because x is 2. So what is k? Divide by 2, right? Divide by 2, divide by 2. K is equal to 2, right? So now it says, then what is y when x is 10? So now that I found k, that's my constant. That always stays that number. Does that make sense? The k is always going to stay that number. So what's my real formula then? It's y equals, what is it? Y is equal to 2x because k is 2. So you use the first bit of information to find your k. So now you can write the real formula. The real formula is y is equal to 2k. There's your real formula. Your real.
Wait, is it 2k or 2x?
I'm sorry. Sorry, 2x. Sorry. Thank you. Y is equal to 2x. I appreciate that. So now we're going to say, then what is y when x is 10? If I put
20.
X is 10. I put 10 in place of X. 2 times 10 is 20. Y is 20. So that's your answer. Y is equal to 20. And you just did it, right? That's direct variation. Direct variation always, if I have a graph, it always starts from where?
0.
0. Right? Remember, if the b is 0, that's your y-intercept, right? Y equals mx plus b. Your b is your y-intercept. It's at 0, so it's always going to start at 0. So, is this... Okay, so haven't talked about this yet. So I'm still on direct variation, just kind of reviewing that from long ago. It was like 3 months ago that we did this, right? So, is this an example of direct variation? That line. No, it isn't. Why? It doesn't start at 0. It doesn't go through. It's got to at least go through 0, right? I guess it could go below, right? But it still has to go through 0. Is this an example of direct variation?
No.
Why not?
It's not a straight line.
What?
It's not a straight
Well,
line.
if it were a straight line. I meant to be a straight line.
No.
What?
Yes. Yeah.
Yes, because it is. Because it goes through 0, 0. Right? Right? It's an example of direct variation. Now, usually, when you have it, it's usually real-life situations, and so it will actually start at 0. So it might be that, or 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 it might be that. Those are all examples of direct variation. So, now, is this an example of direct variation? I'm giving you, first that was pictorial, now algebraic. 2y is equal to 4x minus 6. All right, well, you don't know because you got to put it into y equals. Right? So we're going to divide by 2, divide by 2, divide by 2, because it's got to say y equals, right? And it's got to be just like that or something like that. So we got y is equal to 2x. Uh-oh, minus 3. Is that a...
No.
Why?
Because b needs to be 0.
Say what? I didn't hear that. What? Who said that? You said that? What did you say? Lila, sorry. I can't tell direction. I'm sorry. You know that. So go ahead. What did you say? I didn't hear it again.
B needs to equal 0.
Right. B needs to equal 0 because of that negative 3. It's not direct variation, right? All right. Is this an example of direct variation? Let me think. Let me just get an idea here of what I'm going to do. How about this? X plus y equals 0. Is that an example of direct variation?
Yes.
Let me see.
Well, you got to put it into y equals first, right? You got to subtract x. So we got y is equal to negative x.
Yes, it is.
It is. What's k?
Negative 1.
Negative 1. Exactly. Right. So that is direct variation. But Tiana, if I had done this, would it be, Tiana? If I had added a 1, would it be direct variation? No. It's it's got to be 0 plus 0 for it to be direct variation. You okay? You just look like you're out of it. Oh, you don't feel it? Oh, I'm sorry. I didn't realize that. All right, last one for direct variation. Okay, I gotta be sure. Direct variation. Let's say I have a table, and I have an x and a y. Okay, let's say x is 4, and this is 16. X is 2. And this is 8, and x is negative 1, and this is negative 4. Is that an example of direct variation?
Yes.
How would you know? Was that Lila again?
Yeah.
All right. Somebody else. How would you know that that's an example of direct variation? What's the formula? What's the formula? Y equals kx. Does this fit? What were we going to say, Beckett?
No, your x's repeat.
What? Say it again?
Isn't that what the book says? Like, oh, if none of the x's repeat.
Oh, you're thinking of, what are you thinking of? Is it a function?
Oh, yeah.
Right?
That's right.
You're thinking of it, is it a function? Right. We have to, this is, remember, y is equal to kx. Whenever they say something varies directly, that's the formula. So the question is, in order to get a y, you could multiply x by the same number in all of these. It would have to be the same number. What would you have to multiply x by
4.
to get 16? So 4 times 4. Okay, 4 times 2 is 8. 4 times -1 is -4. So this works. What is k in this case? 4. So this is 4x, right? So yes, this is an example of direct variation, right? Okay, you with me? Does that make sense? You're just looking at your formula. Y equals kx, meaning can I multiply the same number times x in each of these? So I said 4 times 4 is 16, 2 times 4 is 8, -1 times 4 is -4. Yes, it works, right? As long as I'm multiplying everything by the same number each time to get a y, right? Then it works, direct variation. So this is stuff we've covered in the past. Fist to 5, do you sort of get it? 4, okay. Basically, it all stems from this formula, y equals kx. In other words, you're going to multiply x by a number, and always just that number. That number is a constant. Okay, that k is a constant, right? So, in this case, the k was 4, so we always multiplied the x by 4 to get our 16. So it was direct variation. Okay, so that's direct variation. Now, usually when these are taught, they're taught together. Though I don't usually do it that way. I usually teach direct variation first, and then when I do rational expressions, at the end of that I teach this other thing. Because rational expressions means expressions with fractions, right? And it means x oftentimes is in the denominator. And so this is the inverse variation is an example of an equation that has x in the denominator. And we need to see what that's going to look like and how to use that. That is called inverse variation. So inverse variation. Now we're done with direct variation, so I'm going to erase that. We're going to talk about inverse variation. This says y is equal to k over x. I'm trying to think, what should I do first? Let's do the same idea. Let's say if. Let's do another problem, sort of, that's based on if y varies inversely. This is how they'll say it. If y varies inversely, if y varies inversely with x. Immediately when they say that, you write this formula, y equals k over x, immediately. Just like when it says if y varies directly, you write y equals kx, right? You just write your formula immediately. Okay? If y varies inversely with x, and y is equal to, I don't know, 2 when x is equal to 3. Okay? Okay, if y varies inversely with x and y is equal to 2 when x is equal to 3, find y when x is equal to 9. I don't know, something like that. Okay? So we're going to do the same process that we did before. It says y varies inversely with x. So we're going to write y is equal to k over x. That immediately tells us, when it says inverse, that we have to use this formula. K over x, y equals k over x. Now, this is where they gave me information that I can use to find my k, so that I can know what my formula is, my equation. right? So John, is he awake? John, I need you to wake up, buddy. I need you to wake up. Never mind. Go back to sleep. You're gonna have to watch my video and take notes. Okay. All right. Okay. So where are we? Y is 2 and x is 3. So I'm gonna replace that. Y is 2, x is 3. Okay. Now, how would I solve that? You guys talk very softly. Whoever's talking. Yeah, you always, to get rid of a fraction, you always multiply both sides by the denominator, right? Remember that trick? I hope you remember that trick. So we're multiplying everything by the denominator. The 3's crossed out. I have k is equal to 6. All right, so my formula is y is equal to 6 over x. That's my formula. Fist to 5. Do you guys understand how I did that?
Yeah.
Okay.
Whoa, this one makes sense.
Okay, so y is equal to 6 over x. That's my formula. So now it says find y when x is 9. So what's y when x is 9? Y is equal to 6 over 9, which is 3 goes into both 2/3, right? So y is 2/3. Okay? So we found that. All right.
What is this?
If I had something like this, x and y, tell me if this varies inversely. Let me think here. Does that vary inversely? How do you know? Yeah, you can't. I can't just look at it and say, "Oh, yeah, definitely, that's an inverse variation. I have seen those before." Right? It doesn't work that way. You got to use the formula. The formula says y is equal to k over x. So how could we make it simple? What if since I know my x's and my y's, could I rewrite this? What could I do to get this so that the x's and y's are on the same side? What could I do? How could I rewrite this to get the x and y on the same side? Couldn't I just multiply both sides by x?
See, I knew
right?
It. I was just
so that way,
I did it right.
So another way to write this is k is equal to xy.
Whoops, I never knew it.
Right?
See, Gary, that's what I said you should do. So.
Good job. So now we know k has to be the same in all of these if I multiply these two together, x and y. 4 times 4 is 16. 2 times 8 is 16. 1 times 16 is 16. Negative 1 times negative 16 is 16. Yes, they're all the same. That's a constant. K is 16. Whoa. So I could write y is equal to 16 over x as my formula if I wanted to. So this is all going to be on the homework, so make sure you're taking notes. You're going to have to do all these things on the homework.
Oh, but I can't do homework tonight because I'm going to be in Albuquerque at the Sunshine Theater.
So,
that's what it's called.
So did you understand what I did there? Fist to 5, do you understand?
I see what you did there.
Right? We rewrote the y equals k over x to k is equal to xy, where xy equals k. It doesn't matter which way you write it. Right? And by doing that, that tells us that we can just multiply the x and y to get a number, and if that number is the same each time, it varies inversely. Had I done this though, had I done 1 and 14, or 1 and 14, can you say now that that varies inversely?
No.
No, because this no longer is that, it's 14. So even though 3 of them are the same, if one of them is different, it does not vary inversely. Okay? All right, so now we got to see what inverse variation looks like on a graph. It's quite different than any graph you've ever drawn in my classes.
Square.
Quite different. So let's try one. let's try, wait, what's the homework? Let me make sure I don't give you the one on the homework. Okay, so let's say, how did I word it? Write and graph inverse. Write and graph and inverse variation when y equals 2 and x equals 3. Alright, so we're going to do this. We're going to do this one, the one that I did before. It says write and graph an inverse variation when y is 2 and x is 3. Okay? So, first thing is we got to have our formula. So, help me figure out our formula. So, what's the formula? What did you say? Okay, well what do I use? I use y is equal to k over x, right? It says it's an inverse variation. I immediately write that, y equals k over x. And then it says when y is equal to 2 and x is equal to 3. So what do I do with that x and y? Plug it in, right? To find my k. That's why I'm plugging it in. Yes? I'm going to find my k. Once I find my k, I'm going to make x and y back, put it back to x and y. Because I'm going to graph a 2-variable equation, right? So I'm going to find my k. That's what to find k. Find k. That's what I need to do. Find k. And so I'm going to say y is 2. 2 is equal to k over x, which is 3. If I multiply both sides times 3, yes, we did. 6 is equal to k. So k is equal to 6. Therefore, my formula is going to be y is equal to 6 over x. This is what I am now going to graph. Okay, you with me? I'm now going to graph this. All right, so we're going to graph it right here. Okay, the way to graph these, quite honestly, is just use a t-chart. I don't know of any easier way. Maybe there is, but I don't know of an easier way. So we're going to use a t-chart. And it's really important you pay attention to this because it's different than anything we've graphed before. Okay? So here's our t-chart. X, Y.
Oh, I see how this works.
So it's real important you're paying attention, okay? Because this part, you're going to be lost. There's only going to be one on the homework, and I need you to know how to do it. So, what's the word again? What can x not be? What is the, what's the word? How did I always word that? I forget, drawing a blank. Excluded, thank you. Couldn't think of the word. What is the excluded value of x? 0. X cannot be 0, right? Okay, so I'm going to make 0 right down here. And I'm going to do numbers below 0. And I'm going to do numbers above 0. Okay? Now, I'm going to you get to always choose your x's, right? You guys really pay, you guys, I don't know, there's something about this room right now, the attitude, I don't like it. I need you guys to pay attention on this part, okay? Otherwise you're going to be lost, I guarantee it, right? So you are going to, you get to choose your x's, right? Always. So choose x's that are easy. Don't choose like 4. Because if you choose 4, you have 6 divided by 4. Who the heck knows what 6 divided by 4 is? And how are you going to graph that? That's too hard. Choose things that divide evenly into 6, right? 1 does, right? 1 goes into 6. So I'm going to do -1. I'm going to do -2 goes into 6. That's good. And I'm going to do -3 goes into 6. Okay, that's great. So these are actually, this works out quite easily. But you're not always going to choose -1, -2, and -3, and 1, 2, and 3. If it was 8, I would choose not 3, I would choose 1, 2, and 4, right? Or 1, 2, and -4. Something that goes into the numerator evenly so that it's really easy to graph. So let's try it. what is y when x is negative 1?
6.
When x is negative 1, y is negative 6, right? All right, when x is negative 2, y is negative 3. When x is negative 3, y is negative 2. All right, when x is 0, it's undefined. I'm going to write undefined. Okay? When x is 1, y is 6. When x is 2,
3.
Y is 3. When x is 3, y is 2. So we have a lot of points to graph. So now we're going to graph these points. And this is the last thing we're doing, okay?
You graph it like you graph anything else.
Right.
Like,
So now we got 1, we got to go up to 6, right? Okay. So, so make sure you guys are doing your graph in your notes because you're going to need this, believe me. Okay. Okay, good. So here we go. We're going to do our points. Negative 1, negative 6. From 0, 0, I go negative 1, down 6. 1, 2, 3, 4, 5, 6. Okay. Right here, I put a dot. Then I've got negative 2, negative 3. So I'm going to go negative 2, negative 3, right about there, right? And then I've got negative 3, negative 2. Negative 3, negative 2. Something like that.
oh, this is weird.
It's kind of weird, isn't it? And then I have 0 is undefined, so I can't do anything at 0. And 1, 6. So 1, 6 right there. 2, 3, 2, 3 right here. And then 3, 2 right here. Okay, so if I actually did more of these,
Lord Almighty.
if I did more of these numbers, I would start to see this take shape. But it's going to be like this. This is what it's going to look like.
It's going to look like a plant cell.
But it never touches. It never touches the y-axis. So it's going to be, and it never goes past the x-axis either. Never actually touches the x-axis.
It looks like a
Right?
sailboat inverted.
And this is called. Does anybody know what it's called?
Open standard drumming style.
That is called a hyperbola.
Oh, I knew that. I heard that word before.
That is called a hyperbola. And so when you have two things, now it just doesn't look very good here the way I drew it, but it never touches. It's just going to keep.
Yeah, I've seen that before and heard that word. I know this.
It just keeps getting closer and closer to the x-axis and y-axis, but it never crosses. So anyways, does that make sense? So if 0 is undefined, it makes sense because it never touches 0. It can't. Because when it's 0, there is no such thing, right? It's undefined. So it can never touch 0. That's what it's going to look like. So that's what on your homework tonight. It should look like that when you do your graph, right? So you will have to do these this T-chart in order to find it. Okay. So that is basically the lecture. I'm going to turn this thing off.